All right, welcome to this explainer. You know, if you've ever walked past a massive construction site, craned your neck up and wondered how those absolute giants of industry actually stay upright, well, today is for you. We're unpacking the hidden physics and the incredibly high-stakes rules that keep them operational. We're going to take a really detailed look at machine material handling and crane safety, drawing directly from established industrial standards and the Factory Act.
So let's just dive right in and ask the most critical question on any job site. Why do these towering machines, which are built to lift absolute tons of steel and concrete, suddenly collapse? I mean, it's a terrifying thought, right? But the answers aren't some big mystery. Actually, they're entirely predictable.
To get to the bottom of that, we're going to hit 5 key areas today. The actual hazards of heavy lifting, the physics of crane stability, the anatomy of safe equipment, the operator's crucial role, and finally, the golden rules for every single lift.
Okay, starting with part 1, the hazards of heavy lifting, or as it's sometimes known, when gravity wins. You know, it's truly fascinating. When you look at the major terrifying hazards, a toppling boom, a swinging load smashing into a building, or a massive electrical arc from a power line, they almost always trace back to human error. Specifically, overloading the machine beyond its intended limits, or just straight up ignoring fundamental physics. Mechanical failure all on its own is actually pretty rare. It's usually how we apply the machine that goes terribly wrong.
So how do we stop that? Well, we move to part 2, the physics of crane stability. And the best way to understand this is to think of the crane as a giant invisible seesaw. Every single lift, and I mean every lift, starts with a safe working load, or SWL. This is your hard mathematical limit. You absolutely cannot exceed it. But here is the kicker, and this catches so many people off guard. It is not a fixed number. A crane doesn't just have one magic maximum weight it can lift no matter what. The SWL changes dramatically based on your boom length and the angle of that boom.
Just picture the geometry for a second. If your boom angle is high, your load is tucked in tight, right close to the center of the crane. That's a lower radius. That gives you higher lifting capacity and way better stability. But the second you lower that boom and extend the load further out, your working radius increases. And when you do that, you drastically reduce your stability and your lifting capacity.
It all boils down to a pretty straightforward formula. Load moment equals load weight multiplied by the working radius. Let's put some real numbers to this so it clicks. If you've got a 5-ton load at a 2-meter radius, your load moment is 10 ton-meters. But if you move that exact same 5-ton load out to a 5-meter radius, the overturning force jumps to 25 ton-meters. The actual physical weight of the load didn't change by a single ounce, but the invisible force trying to literally rip that crane out of the ground more than doubled. So if you take away one universal rule today, make it this. The further away the load is from the center of the crane, the closer you are to tipping it over. Period. Crane stability is inversely proportional to the radius. Higher radius means lower stability, every single time.
All right, let's shift gears to part 3, anatomy of safe equipment. Now that we understand the massive physical forces at play, let's look at how industrial standards legally require the machinery to defend itself against those forces.
The law actually demands constant vigilance here. Industrial standards state that a competent person, meaning someone with very specific technical qualifications, has to thoroughly examine main lifting machines, like your mobile or tower cranes, every 12 months. But take a look at the lifting tackles, the slings, the chains, the hooks. Because they take an absolute beating from direct friction and stress, they have to be examined every 6 months, no exceptions.
On top of those inspections, these machines are packed with mandatory safety devices that are frankly designed to protect us from ourselves. You've got the load moment indicator, or LMI, and the anti-two-block device. These are mechanical and electronic fail-safes designed to stop an operator from making a catastrophic, physics-defying mistake, like pulling the hook block right into the boom tip, or extending a load way past the tipping point.
But look, even with all those fancy electronic sensors, physical wear and tear is just inevitable. This is exactly why operators and riggers have to be trained to immediately reject wire ropes if they see certain defects. If you spot broken strands, a reduction in the rope's diameter, or this crazy phenomenon called bird caging, which is where the steel strands literally untwist and flare outward like a cage, that rope is a ticking time bomb. It has to be pulled from service right then and there.
Which leads us perfectly into part 4, the operator's crucial role. Because the reality is, all the high-tech safety sensors in the world mean absolutely zilch without a competent, responsible human sitting in that cabin.
A huge part of that human element is spatial awareness. For instance, it is entirely on the operator's shoulders to know and strictly enforce the legal clearances around overhead electrical lines. Working near a 50 kilovolt line, you must maintain a strict 3-meter minimum clearance. Above 200 kilovolts, that jumps to 6 meters. And this isn't a suggestion. It's to stop fatal arcs of electricity from just jumping through the air from the power line directly into the crane's boom.
But things get incredibly intense when a lift approaches the machine's absolute limits, specifically right at the 75% mark.
Yeah, once you cross that 75% capacity threshold, or if you're attempting a tandem lift with 2 cranes, or a blind lift where the operator can't physically see the load, the whole rulebook shifts. It officially becomes a critical lift. You can't just hook up and wing it. You suddenly need a dedicated, documented lifting plan, a full risk assessment, direct approval from a supervisor, and a designated signalman, just to be allowed to proceed.
And honestly, the operator's job isn't even close to done when the lifting stops. Leaving a massive piece of industrial machinery unsecured is a huge hazard, all on its own. You have to follow a strict sequence. Lower the load, raise the empty hook so nobody accidentally walks into it, put all controls in neutral, apply the parking brake, and take the key with you. That ensures the crane doesn't turn into a runaway danger while no one's around.
That brings us to our final section, Part 5, Golden Rules for Every Lift. Every calculation, every single inspection we've talked about today culminates right here.
These are your non-negotiable, absolute standards, the never rules of material handling. Never stand below a suspended load. Never exceed your safe working load. Never, ever ignore the load chart. Because violating even one of these isn't just a minor infraction, it completely breaks that delicate physics equation we discussed earlier and essentially invites gravity to take over the site.
I want to leave you with this incredibly powerful final thought straight from the core of industrial safety standards. Mechanical failure is rare. Most accidents happen simply because safety rules are ignored. At the end of the day, human complacency is the heaviest load of all. So, knowing what you know now about load moments, working radiuses, and that invisible seesaw of physics, what steps are you going to take to ensure the rules on your site are never ignored?